Sir, I'm waiting for a few more to join. So can you
Okay. Yeah. All right. We'll wait for a couple of more minutes then.
So good afternoon, everyone.
Good afternoon.
I think all of you had a good lunch, and hope you had a, I hope you are prepared for the next two sessions. So afternoon first session is handled by Ravi BR. He is working as engineering manager at Travancore Analytics. He is he has been working in this post in Travancore Analytics, and before that he was working in L&D technology for 14 years as a delivery manager, and in Infosys for 1.5 years as team lead. And he has a rich experience in IoT, Scrum, design and implementation of IoT, SaaS, and mobility applications using cutting edge technologies. And we are indeed privileged to have such a resource person from the industry for our session today. In fact, IC4's Trivandrum was instrumental in bringing VBR to our faculty development program. So on behalf of LBS College of Engineering and the Electronics and Communication Department, on behalf of all the participants, I welcome you, sir, Ravi sir, to this session. And over to you, sir.
Thank you, Renzi. Thanks for the warm welcome. So I'm ready to engage with all of you to share my experience on the IoT and Edge Analytics side. So feel free to post your questions if you have anything over the throughout this session on the chat window, and we can have the discussion towards the end of the session if you need any further clarifications. All right. Let me share my screen. Let me just share again. 1 second. So do you all see my screen now? Nancy, are you able to see my screen?
Yes, we can see the screen, sir.
Okay, all right. Thank you. So
Yes, sir, we can see.
okay, all right, yeah. So let's get started on the very interesting topic on the IoT and edge analytics. This is one of the trending technology on the current IT trends. So in this session, so we will have this is the agenda for this sessions where we will walk through quickly on the IoT ecosystem, right? I'm not sure if you already got some kind of a fundamental orientation on the IoT. So nevertheless, we'll quickly go over some of the basics on the IoT ecosystem, like why IoT is about and how the architecture of the IoT will look like, what are the different components involved, and also the IoT applications. Followed by, we'll also look at the IoT analytics, right? And then we'll move to IoT edge analytics. We will also talk about how it is different from analytics versus the edge analytics and its benefits and also the importance. And towards the end, we'll also touch base on some of the future trends, and then followed by we'll have a Q&A and conclusion. So that's pretty much the agenda for today's session. Moving on to next. Any guesses who is this person whom you see on the screen? Anybody? So do you know who is this person? Any guess from anyone?
Kevin Ashton.
Exactly, right. So he is actually the founder of or is also called as the father of IoT. So the session will not be fulfilled if we didn't take a little bit of time to talk on this man, the great man behind this IoT. So he's the one who coined this term IoT. So he is part of this British technology pioneer. So he started way back in the 70s, where he was doing on the embedded internet part of it. And in 1999, so where he was working on PNG, so where he was working on the supply chain optimization, and he wanted to present this RFID technology to the management, and that is where in his presentation he has mentioned this Internet of Things. So even though it was not that popular on 1999, so later it took a decade, almost 10 years, to get the widespread attention on this site. Okay, so let's move to the next. So this is a little bit of a history how the IoT has started. It started way back in 1970, but it took a lot of time in order to reach the stage where we are currently. Right, and so in early 90s, so it was actually the actual idea was the connected devices where, so they were using the Ethernet connectivity, and then we moved into the industrial connectivity things, and in 2000 is where we had all the uh, internet revolution, and where we also had the Wi-Fi and other things coming in quickly. So and then from after the 2016 onwards, so it has become much more in terms of the connectivity with the internet world, with a lot of devices connected. So this is little bit about what is IoT is all about, right? So it is basically a network of the objects, the people. So that is called the things. So which are included in or embedded with the software, right? And the network and the sensors, and in order to collect the data from the devices. So this is IoT is basically the extended of the internet connectivity. So where we earlier had the devices like the mobile computers, all those things, we are able to connect it, and now we have the devices also getting connected to the internet. Right, so this is a little bit of how the scenario was the before the internet, right? So so before the internet, if you see, if you take for example in this scenario, right? So there is something needs to be serviced, right? And what is currently was happening before IoT is the customer will request for an help, and it goes to the technician, and technician has to visit the site, right? And after going there, he'll figure out, okay, something is missing, and it may be the customer information, and what is the, whether it is urgent or you don't know the priority, right? And then finally identifies the problem, and it can take couple of hours to days, or in some cases more than um, the week to fix. But after IoT coming into picture, so if you need something to be serviced, right? So there is always a device which contacts the field service agency independently with all the details. So based on this, we'll be able to make the actionable insights, and then a technician arrives with all the required knowledge and what parts to be replaced in the field, right? And then he also solves or the fix the problem. So it has changed from that sense, from before to the after IoT, right? And then let's look at a couple of the benefits, right? What we got here are some of the benefits which we see in terms of what IoT is bringing to the business, right? So this helps we get a better understanding of the customer behavior, right? How the customer behavior is in terms of the, it can be the his purchasing behavior, the way he's browsed through the products, right? So all of that, and the new business opportunities. So by understanding the behavior of the customer, we can as well have the new services or the new business opportunities out of that. And it is a better utilization of the assets and also the maintenance, right? So Using the IoT, you can also think of in case of the fleet management solution. So where the assets in the field, so if you have the intelligence built in, so you'll be able to utilize the assets better, right? So if something is idle, how long it was idle, whether that is fully occupied for the day, so what are the engine hours, and based on those data in the fleet management, you should be able to manage the assets better. And also when there is something going to be failing, right? So you can predict that early based on the data, and also plan for the proactive maintenance. And the enhanced productivity, so you'll be able to make judgments on and then utilize the manpower, and the productivity will also be increased, just like we saw in the earlier scenario where the servicing can take longer duration earlier. So now with all the intelligence information available, so we should be able to make the decisions much faster. And it will also with all these things, a customer service will be, and the experience, most importantly, you'll have a better experience as based on his behavior, you start showing up the products to him, right? In case of the consumer or a retail business. So, and hence they will have better experience. And when it comes to the servicing as well, right? So if you predict the failure early and then plan for a proactive maintenance, that itself is a good user experience for the customers. Workplace safety. So we have a lot of the safety things about in, like the worker safety. There are now the helmets, right, with the sensors installed, who works on the manufacturing plants, right? So to ensure the safety of the employees. And you can do a real-time analytics, okay, as the data is getting collected, right? You will be able to do the analytics on the fly. And also the historical. So one is the currently what is happening, and then over a period of time, if you want to analyze, you have all this data in order to make the analysis. Right. So let's move to the next. So what are the key components of the IoT system? So there are mainly 4 key components. So there's a device, right, which is the thing, and there's network, right, which helps in collecting the data from the devices. And then there is a data processing element which process this data which is collected from the network, and then comes the user interface where we'll be presenting this data. So device, network, data processing, and user interface, these are the main key components in the IoT ecosystem. So when it comes to the sensor or devices, so there will be like a wide range of sensors like temperature, humidity, gas, right? So all these different sorts of sensors are available, which we can leverage to monitor the different parameters, right? And then the network or the connectivity, right? So when it comes to the network or the connectivity, so it is always difficult to find one single communication solution which fits in for all, right? It is also because the diversity and the connectivity between the device and the processors is very important, right? And it also depends on the application, the business application which we are developing. So there is always a need of unique set of requirements, and hence there are different network or connectivities available, like LPWAN and Bluetooth BLE. So there is cellular 4G, and the 5G is already on its way, and the mesh protocols, the Wi-Fi, RFID. So these are different network connectivities available. So on this IoT network connectivity, it is mainly based on the range, bandwidth, and the power consumption. And of course, the cost also matters. So this is just a quick glimpse of how the different IoT connectivities are compared with respect to the range, bandwidth, and the power consumption. So if you see here, so the you will have the LP WAN, right? So as part of that, you will have LoRa and all those things. So it also gives a good range. It will be like 8 to 10 kilometers of the range in terms of the range, and also has the good bandwidth for the connectivity. So likewise, we have the Bluetooth is more suitable if you have in a very close to the device and you wanted to do certain operations. Then Bluetooth is an option for the connectivity. So similarly, we have this 4G, 5G. So that's also, it has a good range as well as the data bandwidth and the power consumption. Right. Let's move to next. And now let's look at how this connectivity versus the different vertical or the businesses, right? So if you see on the key IoT verticals, we have the industrial IoT, right? The smart meter, smart city, smart building, smart homes, and all sorts of the wearables, right? The health bands, the connected car, and also the connected health, retail, logistics, and also the agriculture. So if you see this with respect to each of this IoT vertical and also the available the connectivity. So the LP WAN is where it actually suits most of the verticals. So likewise, connected health, it is more on the cellular network. And smart home, it's mostly the BLE, Wi-Fi or Zigbee is more preferred, right? So considering in the home, it will be we are close, and then we'll be able to make connect very nearly to the device, and also through the Wi-Fi we can as well interact. And similarly, the RFID and other things which will be more suitable for the logistics with the RFID tags on it, and also the retail like the smart cart, those kind of things. So LP1 is more covering majority of the IoT verticals, right? So now these are some of the emerging IoT connectivity apart from what we have seen here. So there is a standard based LP WAN, so which will have a low throughput, and it is suitable for indoor as well as the outdoor. And as we discussed, it is more for the industrial IoT, remote monitoring kind of solutions, smart building and smart cities. And the 5G is another upcoming trend, so where it has the high throughput, and it is largely used for the outdoor network. It's mostly on the mobiles and telemedicines, right, and also connected vehicles, and also mission critical IoT. So where you need the decisions are very critical, and it should be fast. And in those kind of scenarios, we can have the 5G connectivity. And Wi-Fi 6 and the Bluetooth 5, all these things are enhance of the current Wi-Fi and Bluetooth, which is also largely for the indoor, for the home and enterprise kind of a thing, for the smart home and wearables applications. Okay, so now let's say, so we talked about the connectivity part of it, right? and the data processing, right? So when it comes to the data processing, so since there are large amount of the devices, there is the data collected from this devices is homogeneous, and also the space which is required for processing this is also very huge. So that is where the cloud solutions for this both storage and processing becomes the backbone for the data processing, right? So before that, we used to have the on-prem kind of servers, and then whenever you have more data, you have to keep scaling up or adding more RAM and those kind of things. Now we get the cloud solutions, so it has become easy to scale in terms of the compute power which we need for processing the huge amount of data, right? So though all the different components on the IoT is very important, the data processing is very challenging, and it's also crucial. It is because of the volume of data which you need to process, right? So basically it will have three steps. One is the input is nothing but the raw data which is collected from the machine, right, or the device or the sensors, which will be in the readable form. And then that gets fed into the processing step, where it uses different techniques, right, to calculate the data and produce the meaningful information. And the output, you will be having this meaningful information which can be stored further, and you can have the insights using the graphs, reports, and other mechanisms. So that's on the data processing. So now let's look at the IoT platforms, right? So there are multiple IoT platforms available in the market, okay? And we can always select the one which will be ideal depending on the challenge which we are addressing, the problem which we are solving, and the kind of an application and amount of the time and resource which is required, and what is the cost which we can spend, right? So depending on that, so there are the open source platform as well as the paid platforms. And main criteria for selecting any of the IoT platform is you to check for the suitability, whether it really suits the application which we are developing, whether it has all the different services which it can provide, and stability. So how mature that particular service which we are going to adapt from the particular platform. So is it there for quite long, or there are already proven solutions built on top of that service? So those are all certain things which we should look at it. And scalability. So as we keep adding more and more devices, so there will be more data coming in. So we should be cognizant about the scalability aspect. So it should be scalable both horizontally as well as vertically. And security. So how the one of the scaling factor is, as soon as we say the cloud, so the security is plays a vital role. So hence how and what kind of security measures which is being supported by the cloud platforms also matters. And the data ownership, right? Once you put the data on the cloud, so whether the ownership will be with them or with us, and how, if you want to get the data back to our data centers, and what are the ways and means we can get it, right? So all of that needs to be looked at it. And of course, the pricing also plays an important role, as it is based on, there are multiple pricing models, like the pay as you go, or it is a subscription based, right, as a annual and monthly billing. So we should adapt that, and then we have to look at the cost of each services which we use and the benefits we get. And the performance, okay, so in terms of the latency, speed, and number of zones in which it is available, that really matters to get a better performance. And the additional tools like the backup and the monitoring and control tools, right? So all of that really matters. So these are all some of the things with the big players in the market on the IoT platforms like the Amazon, AWS, Microsoft, Google, IBM, Cisco, right? So this is just a quick glance of the comparison of the different platforms and what type of protocol it supports, right? And what are its main functions, right? And what it supports when it comes to the edge computing, right? So AWS, Cisco, Google, IBM, Microsoft Azure. So almost all of these platforms has the support for the edge computing, right? So in case of Amazon, there is this IoT Greengrass and FreeRTOS as well. Cisco has its own edge computing solution, and Google as well as a edge TPU chip, which is doing this edge processing or computing. IBM has the IBM Watson platform has this edge computing capability as well, and Azure has the Microsoft Azure IoT Edge, which is a part of the IoT hub of the Microsoft, right? And so these are all some use cases. It's not just limiting to only those use cases. Like AWS has most use cases on the smart city and agriculture related, right? Connected home and those kind of things. Similarly, healthcare, retail, manufacturing, there is Azure and Google, as well as the energy and smart parking and transportation side. IBM also has the use cases which has been developed for manufacturing and smart buildings, right? And Cisco is more on the connected vehicles, manufacturing sector, and the smart city side, right? So then comes this, so we did talk about the connectivity and the devices, platform, data processing, and then the final thing is on the user interface, right? That is where you'll start to see the data, right, which is being captured and then processed for display. So, and that's where the user interface is one of the key because this is where the experience matters, right? So this is not just limited to like the phone or the web application. It is also the user interface on the HMI. Like here you see the Nest thermostat, right? So on that you can see the temperature and you can also set the temperature. So all that really matters. So we'll also have this voice-based devices, right? Like Amazon Echo. And the Google Home. So all this through that you can interact with these user interfaces and make the commands and get what you want to do with this devices. So you can interact. So and hence user interface is very key, and a good user interface can give a better user experience. So though we have collected a lot of data and made good insights, if it is not presented well at the end, so it may not be giving a better user experience to the customer, right? So this is a quick glimpse of the different IoT application, right? So on the industrial and manufacturing sector, if you see, there's some of the use cases you can think of is the real-time asset monitoring, right? So you want to track the assets, you want to prevent the maintenance of a factory machinery, right? When it is can be becoming due for maintenance, right? When it can fail, all that you can track the asset tracking and also the safety systems of the manufacturing plant. So all that will be some of the use cases. When it comes to the healthcare sector, you can have this connected healthcare and remote patient monitoring, right? And on this pandemic days, this is also very crucial, right? And contactless thermometers, right? So without even contacting each other, so you'll be able to get the readings from the contactless thermometers. And the predictive healthcare, so based on the data which has been collected, you will be able to predict. It can be an infection, or it can be you can predict based on the MRI scans and other things. You can also predict certain diseases and then have the prescriptive upfront. And the wearables, which really helps in collecting a lot of data with respect to your habits, the health habits, and your fitness related heart rate and all of those parameters, and you can judge based on that. You will get a lot of insights from that data. And in the transportation, right, so you can have this the connected cars, right, and traffic management. The you can track the vehicles, right, where it is and what location, and the toll and ticketing. Those are a couple of things. When it comes to e-commerce, do have this smart home inventory management, right, and smart supply. Maintenance and warranties also can be tracked easily. So when is the warranty ending, when the maintenance is becoming due, all that can be tracked. Right. So now let's look at the architecture of the IoT. Right. So an IoT architecture will be mainly consists of the 4 different layers. Right. The bottommost layer is the sensor layer. Right. So that is where we will have this physical objects, or the sensors, or also the devices. So it can be the smart bulb with the sensor. So it can be a smart camera with the sensors, right? So it can be a medical equipment with the sensors, right? All of those. It can be a transport vehicle with the sensors. So that is the sensor layer. So where you will have the objects and the sensors installed. And on top of that, you will have the network layer. So this is basically the gateways and the network technologies like the Bluetooth, Wi-Fi, RFID, right, and this LPWAN. All that comes under the network layer. Then comes is your data processing layer, and that's where we will have the rule engines, analytics, storage. So all of that comes part of the data processing. So once it has been collected, processed, and stored, then comes is the application layer, where you can build the smart applications, and also you can manage it. So it can be the apps, it can be web applications, it can also be some of the human interface HMI devices with the interfaces which we can interact. So that is on the different layers of the IoT architecture. Right, so it basically has sensor, network, data processing, and the applications which we can build on top of the data which has been processed, collected, and stored. All right, so how does the future IoT trends looks like, right? So if you see based on some of the data which is being gathered, right? So in 2015 somewhere it had around 15 billion devices, and now if you see it is gradually increasing year on year, and then 2019 it was 26 billion, and I'm sure now 2021 it is already crossed more than that, and the future trend looks to be by 2025, so we'll be reaching at least 75 billion devices connected, right? So as the more number of devices are getting installed all over the world, so there is also certain challenges, right, in terms of technology which is also coming, right? So that those are all things like the it can be the vulnerability attacks, right? The security is also becoming a crucial thing, right? And this security is becoming one of the key, and also the since the large volume of data is pumped out, right? On very high frequency rates, and how do we process this and store this, and we have all the cloud infrastructures in place, but again it all comes with the cost, right? So that's where there's a lot of new things coming in, and edge analytics is one such thing which is also getting evolved out of this large number of IoT devices getting installed. So we'll talk about that in the coming slides. All right. Let's move to next. So now let's talk about the IoT and analytics, right? So if you see here, so there is in the IoT and analytics, so there is the business, right? So the businesses can be education or training, it can be industrial or manufacturing, healthcare, it can be e-commerce or media or sports, right? All of the businesses, each of these businesses will be one or the other way having the IoT applications, and they will have the IoT devices and sensors. So if you look at the education and training, right, so you will have the smart boards, mobile apps, tablets, right, all of this different things, the way we can interact and have the IoT part. And when it comes to industrial and manufacturing, so you can have the vibration sensors, pressure, temperature, gas, humidity, and the water level. You can have the level sensors. So different sensors you can install on the manufacturing plants and the industries in order to get certain data out of that, right? And when it comes to healthcare, you will have this smart thermometer, wearables, and all those things, smartwatch. And similarly, the e-commerce and media sports as well, you will have the wearables and the smart shoes, right? And smart cart. All of this will be having the one or the other IoT devices and sensors in order to collect certain data points, right? So now the IoT devices or sensors collects all of this data. So then what happens is it moves to the centralized storage, right? So the data gathered by the IoT devices will be moved to the centralized storage. And it can be a cloud storage, and in some cases it can be a data warehouse. It can be a private or the public data warehouse where all of this data is getting stored. And then what happens is you will process all this data, right, using different techniques. It will be the machine learning models, right, different more machine learning techniques you can use, and then analyze this large volume of data, and then from that you will have the insights into what is happening on a particular business, and from that you can have the actions taken accordingly. So that's how the IoT and analytics scenario looks like, right? So just to summarize, so business uses this different IoT, adapts IoT to collect data, right, for using the device and sensors, and then that gets stored into a centralized point as the data lake or data warehouse. And then once you have the data, on data you do the analysis to gain the insights. So what if you take a scenario where business or organization, right, can move this type of data centralization and then do an analysis even before this data centralization, right? And that is where the edge analytics comes into picture, right? So now let's look at the what kind of problems are getting emerging out of the IoT and analytics, right? So with this emerging IoT technology, right, there is an increase in amount of data, which we have saw in the previous slides as well, there's large number of devices are getting deployed. As the number of devices increase, there is also this volume of data is also increase, right? And the organization wants to collect all of this data, and they wanted to analyze, they wanted to understand the behavior pattern, right? They wanted to predict failures faster, they wanted to take some actions. But the transmitting this data to a centralized point and insights, right? And back and forth between this device and the cloud, it always takes a time, right? Because it has to go to the cloud system and it has to process it, and then based on the outcome, it has to make some decisions. Then it has to notify back to the edge device, and then that device can take a action, right? So hence this creates a need of providing fast analysis, right? And decentralized insights from the data which has been collected from the edge of the network. So that becomes a vital or a key role to do the analysis at the edge and then make the insights faster. Okay. All right. So let's look at some of the examples, right? If you take, for example, an autonomous vehicle, right? So now the autonomous vehicle is another trend where which needs to make a quick decision, right? So when we are driving the autonomous car, assume it is about to braking whenever it encounters an obstacle, right, on the road. Something is coming crossing the road, so this particular vehicle needs to make a decision very fast. It should be quick. It cannot take seconds to make the decision, right? So the decision speed requirement in that case is faster, right? And any cloud computing solution cannot provide such a fast decision making by taking data, store, analyze, and provide back. So, and hence in this kind of scenario, the edge analytics really play a key role, right? Let's look at the another scenario. So if you take the hotel management, for example, right? So if a microphone is been installed, and then based on how and what tone customer is voice sync, right, at the receptionist, you wanted to make certain decisions and understand the pitch of the customer, and then how you can increase the customer satisfaction, right? Of course, if he is very unhappy, you will be talking in loud voice, or so based on the voice as well, you will be able to gauge whether that customer was happy on that conversation or not happy, and then you can make certain actions in place. So that will also increase the high customer satisfaction, right? So, and hence keeping all these things, the edge analytics is becoming very key, in which you are going to get the insights very close to the edge of the device where the data is getting collected, rather than moving to the centralized storage and then taking the insights, right? All right, so now let's look at the edge analytics. So what is this edge analytics is about, right? So edge analytics is nothing but it's a method of collecting the analytics at the edge of the device, right? So this basically performs analysis at a non-central components of the IoT system. So earlier what we saw is it collects the data to a centralized storage, that is the cloud system or the data warehouse, and then performs the insights, and then it sends back based on the insights certain action backs to the device to perform. Whereas in edge analytics, it happens in a non-central, so which is close to the IoT device, right? So it can happen at the sensors, it can happen at the switches, and also the connected device itself. So the data processing and insights, and then actions out of the insights will happen at the sensors, switches, or the connected device. That is nothing but the edge analytics, right? So in other words, if you can also say that this is the insights will be gained closer to the device where the data is getting gathered. So if we are gathering the data from sensor, the sensor can itself process that and make certain actions, right? So instead of relying on the central locations, which is always takes time to process it, store it, and then give the actions back to the device, right? Can you go on mute if you are not talking? Thank you. Hello? Okay, thank you. So now let's look at the scenario of the IoT and edge analytics, right? So previously we saw the IoT and analytics, where it moves to the centralized storage and then performs the analysis. So whereas with the IoT and edge analytics in place, the different businesses can collect the data, right, from the device and sensors, and then it can have the edge analytics, which is between the device and the central storage. Sometimes it will be part of the IoT device itself, and sometimes it will be close to these devices, where it can be a gateway where we will have this intelligent embedded part of that, which makes the processing and the insights close to the device. And even after doing this, the data processing, right? So you might be wondering, so if we are doing all the processing right at the edge itself, then are we thinking of eliminating a central storage? No. So the idea of edge analytics is to make quick and fast decisions based on the data which is being collected, rather than waiting for data to transmit and then make the analysis. So having said that, this process data will be still goes back to the centralized storage, where you can do more of the historical analysis, right, and some kind of the aggregation, right, and then use it for your future analytics. So what we do at the edge is more the real-time actions which we need, right? Such things will be done at the edge analytics. The rest of the steps of after this, going to the central storage and using the cloud storage for storage, getting the insights, that remains same, right? So I hope this clarifies how the IoT and analytics will be different from IoT and edge analytics. So we're not eliminating the cloud here, but we are bringing in a step with that. The fast insights can be done at the edge of the device. Okay, all right. So now let's look at the IoT edge analytics architecture, right? So this has key component like the device or the sensors, right? This analytics happens at device or sensors. And there is the edge device. It can be a gateway which is connecting multiple devices or sensors together, right? And we will have the analytical model which runs on this edge and then provides the edge analytics. Means the analytics or the insights which are required for the edge of the device, right? If device needs to make some action based on the data which has been collected, and that is what such decisions will be made using the edge analytics. And after that, it moves to the cloud, and that's where the aggregation and the processing of this data which is collected from the edge will happen, and also it will be stored, right? So if you see in this, there is these edge devices, right? Usually it is will be having the general purpose devices, right? It can be running different OSs as well. Some can be on the Linux, some on the Android. Okay. So, and often these devices, it can be the Raspberry Pi, right? So it will be operated by the battery, right? So, and these edge intelligence, right? So they run computation on the data which they receive from the sensors, and then in turn it will also send some commands to the actuator. So for example, if a temperature sensor is sensing the temperature, and if the temperature is going high, right, behind the threshold which has been set, then it should automatically, okay, decrease the air condition temperature, right? So it should set to the low so that the cooling can increase. So on that kind of scenarios, so it can make those fast decisions based on the data which is coming. And the gateway, which is basically, it is a full-fledged operating system, right? But this will have the constraint on the more on the CPU and the memory and storage. So it will not be like the heavyweight like the cloud system. So it will be very lightweight on that. So this can act as an intermediate between the device and the cloud system, right? So where it can process this data and then give it back to the cloud for a future insights, right? And then if you see on the edge computing side as well, so there are a lot of activities happening, right? So the Raspberry Pi, okay, which is one of the, like a gold standard for any of the computing on the device side, right? So the Raspberry Pi 4 especially, it takes this Pi to the another level, right, which has comparatively good performance, and it can process the data, okay, the video, the 4K video data as well. So that is a good improvement on the Raspberry Pi device. And likewise, Intel and other the chip manufacturers are also working constantly on the hardware part of it in order to accelerate the machine learning part, which can be done at the edge and which needs the compute power for the edge devices, right? So that's on the IoT edge analytics architecture. So let's move to the next. So now let's look at how this analytics versus the edge analytics, right? So edge analytics and analytics, if you see, it will have similar capabilities, both process the data, right, and also provides a meaningful insights. The only exception here, it is this analytics in case of edge, it is done more closer to the device where the data is getting gathered. Whereas in the other case, it is in the place where the central storage. And if you see the major difference between the edge analytics and the regular analytics application, right? Since this needs to work on the edge devices, right? We will always have this constraint of the memory processing, right? And also the communication constraints. As I already mentioned, these are all lightweight computing capabilities at the edge, and hence we will not have like a luxury of the cloud where, okay, if it needs more computing, more memory, we can always scale vertically, right, in case of the cloud system. But it's not the case in the edge. So we have to be really cognizant on the way we use the memory and the processing power. So that is where the optimizing the applications to work with these constraints is really the success for the edge analytics, right? So that's the only key difference when it comes to analytics and edge analytics. It does takes the insights fast closer to the device, and also the applications which were designed to work on edge analytics to be such that it is to be more optimized, keeping memory, processing power, and these constraints in mind. Okay. So now let's look at what are the benefits which we are going to get out of this edge analytics, right? So how the edge analytics can benefit the organizations or a business, right? So these are few key benefits which are offered by the edge analytics. So one is the reduced latency, right? So it will be more efficient to analyze data on the faulty equipment, right? And immediately you can shut up or stop that instead of waiting for sending this data to centralized data, analyze it, right, and then take a action. So that way this will be helps the fast decision making, right? And next is about the scalability, right? So when your accumulation of data increases, right, the strain on the central data analytics resource, okay, it is also becomes high. So whereas if we have the edge analytics, okay, can do this distributed computing, right, with the analytical capabilities, right, by moving from centralized to decentralized, right, where the data is collected, then it will be more and highly scalable, right? So for example, if you have the data which is coming out of the device, right, for every say 200 millisecond, right? So you will have a lot of data points coming out of this device in a minute and to the hour to day, right? So instead of collecting all of this data and putting into the centralized, if you can make the certain decision and insights at the local and then give them aggregated data. So maybe you don't need every 2 milliseconds of data. All you need is that after making this aggregation, you need like every 5 minutes one data point or every hour one data point. So depending on what kind of the after edge analytics you need to do, right? So based on that, you can reduce the number of data points which needs to be transferred to the central location, right? And it will also increase the security aspects. So in most of the cases, the data which will be very sensitive, right? So they expect the data to be gathered and stored near to where it is being getting collected. So they don't want to expose all of that data to the cloud ecosystem. So that way, so we can have the better security mechanisms in place by putting the firewalls and required things in the decentralization, right? So devices can be controlled using the IP, and we can protect the data transmission, right? So even if somebody is trying to hack, it will be hard for bringing down the entire network, as you will have a lot of the hidden devices, right, which is doing the different things which are not exposed. Then a centralized server where it is just one point of contact which you can easily hack, right? So that way also it is more secured when it comes to the edge analytics. And connectivity, okay, it will have the robust bandwidth, right? And connectivity. So potentially this ensures that the applications are not disrupted, right, in case of the limited connectivity. So at some places, right, in the rural or the manufacturing plants where you will not have the good bandwidth for the internet connectivity. So on those cases, this will really helps to make the decisions faster, and it will not get disrupted because of the connectivity issues. And of course, the it will reduce the expenses, right? So as we are not if you take that example of the storage, right, instead of storing 100,000 data points, if you store the one third or uh, one fifth of the data points, right, uh, there is always the cost of the cloud system is based on the volume of data you store, right? The compute power you use to process that data. So as the number of data points you keep on process on the centralized reduces, it also reduce the cost aspects, right? And also every data in and out is always charged on the cloud system, so that also can be minimized, right? So uh, more than all of this, I think the quick and faster decisions at the edge is the key benefit of going the edge analytics versus the analytics at the centralized place. All right. Now let's look at the some of the importance of the edge analytics, right? So as we already talked, this enables faster decision making, right? Mainly in case of where you have the bandwidth is very low and you wanted to still make sure that the decisions are done faster, then this is where the edge analytics is of importance. And then, so given the lot of businesses are increasing towards this data-driven decision making, right? So every business wants to make decisions based on the data. So in this case, the edge analytics is a significant, and there are a lot of tech gains like Apple, Google, Amazon, IBM are investing on it. So if you noticed in the last year, January, the Apple has acquired this edge-focused AI startup, Exonor AI. Okay, so in order to have this capability, Apple plans to run this like deep learning analytical models on the edge devices. Okay, so it can be the phone or the camera or the device itself, drones, and some of the embedded CPUs in the phones. So in order to get all those kinds of insights, so Apple is doing towards that with that acquisition of Xnor.ai. Similarly, the Google, Amazon, Microsoft, and IBM, Cisco, all of them have the focused on this edge IoT product. So they already have that, and they are constantly working towards enhancing this the IoT edge products. So that is one of the things. So the entire industry is moving towards that. And as we talked about, edge analytics definitely helps, right, in making the faster decisions, right? So as we discussed on a scenario where in an autonomous car, you wanted to make the decision, which will be like a very quick in terms of should be milliseconds, not more than that. So it's not only helping for that, it's also if you want the data to be collected from various devices, right? And this is also increasing because the number of devices are increasing. So this is rapidly increasing. And hence, what happens if we have the low bandwidth, right, between the server and the edge device, right? The speed at which or the rate at which the data needs to be transferred, okay, from the edge to the server and server to the edge will not be sufficient even for less time sensitive application. So we talked about an application of autonomous where decision should be fast. But even if it is not a millisecond, but after a few seconds you want to make a decision on other applications, right? So even in that scenario also, the edge analytics plays a vital role where the bandwidth is a low bandwidth, right? So and hence in those application scenario as well, the edge analytics plays an important role. So, and the other thing which we already also saw and discussed is the only you can plan to have the relevant data which is being transmitted from edge to the cloud. See, before edge, what is currently happening wherever there is no edge analytics in place, it is collecting all of the data and then it is just pumping into the centralized storage. And then this cleaning, cleansing, and all of that is happening at the central storage. At the first place, since you are putting a lot of data transmitted from the edge to the cloud, the amount of data which is pushed to the centralized storage is humongous. So hence, this edge analytics will help in reducing that data transmission and also thereby the cost. So lower the data transmission we are doing or the relevant data transmission we are doing instead of all of the data, then of course the cost of this will also be effective than putting a lot of data on the high cost, right? The other part is that the businesses can also see the big picture by aggregating this data from different devices. It can be thousands of devices. So this is not going to compromise anything on that side where you wanted to have the big picture by aggregating the data from devices. Since you are transferring this relevant data to the centralized storage, you can still make those decisions at the central place. And if you are looking at the trend, right, the entire global, the world edge analytic market itself is alone can grow up to 31 billion by 2027. So that means there's a lot of investments happening and around this edge analytic market, right? So we'll also see in the coming slide why and how this data point is coming at, why the business are investing more on this towards the edge analytics, right? let's move on. So now let's talk about the business need, right? So we understood the benefits. We also understood the importance of the edge analytics. Now, what are the business need? So how a business can decide whether they need edge analytics for their business or not. So all they need to do is that to try answering these questions, right? The first one is, does analyzing data in real time improve the productivity, right? So if analyzing data on a real time helps in improving the productivity, then they should definitely go for the edge analytics, right? Do you need a solution that can scale over time? So if a business is planning for a solution which should scale it smoothly, right, over a period of time, so then if the answer is yes, the edge analytics is the solution for that. The other thing is that does your business is an industry that require fast response when an unexpected change happens, right? So whenever there is the unexpected data behavior, right, data, the change is happening, and based on that you want to make a quick, right, decision, and you need to respond fast. In that case as well, the edge analytics will be useful for the business. Okay, so if any of this is S, then a business should look for adopting the edge analytics. A real-time data analytics is required, but whether it is going to help by improving the productivity, do you need to scale it, right? Or you need to make a faster decision whenever there is some change in data. So based on this, the business can derive a need of edge analytics. Okay, so that's about that. So now let's move to the some of the case references, okay, where we have involved in developing the edge analytics solution, the IoT and edge analytics solutions. So before going there, I just wanted to check if it's good so far on the different concepts which we went through in terms of the IoT to IoT analytics to IoT edge analytics. Are we good, or do you need to take a pause and ask any questions at this point? Is it clear for all of you? Are you following?
Yes, sir.
Okay, so let's move on and look at the edge analytics case references. That case. Okay, so now let's look at the first one. This is about the IoT automation, right? So the home automation and also the healthcare and oil and gas, right? So let's look at the IoT on the HVAC or the home automation side. So this particular application is basically having a device which is being placed near to the HVAC system, right? Like the chiller and air conditioner, right? And which has different set of sensors installed in it, okay, to measure the temperature, pressure, right, various parameters. And this particular the device or a sensor box is built on Raspberry Pi, and the interaction between this device to the cloud, it happens through the Wi-Fi and MQTT protocol, right? So the data is getting pumped from the device to the cloud system using a MQTT protocol over Wi-Fi. So, and the cloud ecosystem, we are using the AWS for the storage here, right, and also the processing. So the main use case of this is that, so based on the temperature, pressure, and other data points which has been collected, which can detect any the faults which can occur, right? That can be detected fast based on this sensor values, and it can provide easy access to the customer, that is the end consumer, as well as the contractor. So these HVAC systems, the chillers or the air conditioning, which will be installed by different or more maintained by different contractors, right? So they can get notifications if there is anything abnormal happening in terms of the device and the sensor values. So there are thresholds set for each of this sensor, and if the it is getting threshold is getting crossed, then there is an alerts getting sent. So those alerts are classified into, like, if all is going good, then it will be green, and if there is something changed but it is not so critical, then it will be marked as an yellow. But if it is no go, it is to be addressed immediately, then it will mark it as red, right? So in this these are the main key the features or the benefits. Is it has the user management, where you can have the different organizations, right? And then you can manage your administrator, that you can bring in different level of users like technicians, contractors, and you have the device management, wherein you can add these different sensor boxes, right? You can configure the different sensors, you can configure the thresholds in order to capture the data. That's the, and it provides these different dashboards where you can see the sensors status, right? Whether what is the status of the sensor. Is it green, all green? Are there any yellow, or are there any critical notifications to be addressed? And also there are historical analysis based on the data which has been collected. So there are graphs which you can be used. And based on this, you can as well plan for the maintenance activities, right, of the AC system itself, or the sensor device itself. It needs to be maintained, then that can be planned based on this data, right? So in this, when we started initially, so this was following similar to like IoT analytics, right? So this was getting the data from different sensors, applying the storing it in a centralized place on the Amazon cloud with the MongoDB, right? And then this data which has been collected was being analyzed for giving this detecting the fault and sending the alerts, and also decide on the maintenance activities. So whereas we recently started on this introducing the edge, right, computing, the edge analytics at the sensor for analyzing the sensor values at the edge before even it gets put onto the cloud. So we have this the temperature data and the RH values. So based on this, we can analyze the data and predict the future values. So if the temperature from the past 1 week, right, we can look at that, and then we can plan how the temperature values will look like for the future. And then depending on the threshold which has been changing on the real time, it can respond back to the actual device, right? So, and also it helps in predicting the status when it can turn red, right? So those kind of analysis are done on the sensor values. And the other thing is on the location based analysis, right? So the sensors failure may be different for different geographic locations, right? Because each location will have a different temperature level and the humidity, right? So, for example, in Kerala you will have a different, and in Karnataka it is different, and this is state to state. And then when you take from uh, India to rest of the world, like US or the other places like in Europe, so it's always there is a variance in the temperature and humidity. So based on that as well, you can make the analysis on the data, right? So the same location, then the sensor performance can also vary, right, with respect to the altitude and the basement position where it is being placed, right? So basically, we can make those kind of analysis which we plan to do on this sensor data, and then we can have the sensor failures, including the effect in the prediction algorithm. So this is about this particular use case. Now let's look at the another use case, right? So this was for the energy and manufacturing plant side, right? So where they need this instant response whenever there is any machine fails to work, right, or it needs maintenance. So they need a quick analysis at the edge before it fails. It should identify and then make a faster actions in the uh, plant. Okay. So this is basically the remote monitoring solution for the energy plant. So this is something which I done in my past experience as part of the different IoT projects, right? So the goal of this is to also reduce and address the energy or power consumption, right, of the plant year on year. So this has the gateways which is being installed in the field, and the energy meters or the industrial meters connected to this gateway. And gateway is intelligent enough to collect this data, and it aggregates so data and then provides out like every 5 minute data point. So it does different kinds of aggregation at the edge itself, like 5 minute hourly aggregation and daily. So based on this data, so at the central cloud system, so the Azure cloud has been used. So where it performs further aggregation on like the weekly, monthly, and yearly aggregation to make the insights, right? So this also has this device management capability where you can manage these different gateways, the and also the manufacturing shop floor with the different departments, right? And what in each department, what kind of devices have been installed, right? So the data is getting processed on the real time as and when it has been received from the device, right? So this also the outcome of this data will be analyzed and provide insights using the web application dashboard, and also there are certain BI tools like the Microsoft Power BI, right, where this data can be imported, and they can do the further analysis on this particular data, right? So these are a couple of case references which I wanted to touch base, right? This is another machine learning use case, right? So it's also called the federated learning, right? So usually what happens is that you will have this uh, the situation is like nobody wants to share their data, right? But still they wanted to analyze and make the insights using the different models. So this application basically facilitates such thing through the federated learning. So meaning, so if I have a data and I wanted to use the model, right? So of someone else and then get the insights without even sharing the data. So one way of doing is that I share my data, then there is a model which takes this data as an input and processes and produce the output. But if I don't want to share the data, but still I can leverage the ability or capability of a model, then that is where this becomes very useful. So all you need to do is that you can download the model. So this through this application, everyone can share that model basically, and people can just download this model and then use this model with their data and then get the insights. And then if they are making some improvements to the model, again they can upload this model back and others can use that model and train with their own data. So that way, without sharing the data, the model gets trained with multiple data sets, and that's how the model will become more robust for use. And also the accuracy of the model will increase as the more data sets are getting trained by that model. There are more issues will be start popping up, right? So that is called as a federated learning or also shared learning on the machine learning side. Okay. All right. So now we're almost towards the end of the session. So let's look at the emerging technology trend, right? How we are moving from the IoT analytics to IoT Edge analytics to what next, right? So if you have seen, right, the during pandemic, nobody would have been imagining that the way it is started, right, 2020. It has forced a lot of the businesses to adapt the digital transformation, right? It doesn't mean that we did not had the digital transformation before, but the need of digital transformation journey has been increased rapidly over the past year or so after this pandemic. The large number of businesses have moved online, right? In the past couple of months, right? It is much more than the last decade, right? So there is a lot of stake on the coming years, right? On this current and coming years with respect to the digital transformation journey, right? So the question is whether the mainstream technologies, right, like the data analytics, AI, will remain in force, or we will have new forms of technology domains coming in this year and in the future, right? And that is what is the one such technology trend is about this IOB, right, which can be dominating in the current and coming years, right? So while the IoT is constantly evolving and we are seeing it is expanding both in terms of the complexity, right, also in terms of number of devices getting connected, right, with each other and computations, the different types of computations which we saw, edge and as well as the central storage, right? And so this is where this emerging new trend called Internet of Behavior, right? So, which is nothing but the extension of the Internet of Things, right? So, this is the upcoming trend which we are seeing in the coming years. So, the companies are all set and the businesses are all set to take advantage of this to monitor the consumer or customer behavior, right? Um, so some of these tools will become very effective, right? Including the location tracking, right? The facial recognition. So all of this, you will be able to make the judgment based on the behavior of the customers. So even on the Gartner prediction, so it's been also mentioned that by 2025, almost half of the world population will subject to at least one of the Internet of Behavior program. Okay, whether it is commercial or a government body. So there's one or the other programs which will get spin off on the Internet of Behavior side. So we will have data, and from the data we will have the information. From information we will also gain the knowledge, right? From knowledge you can rise to the wisdom, and that's how the Internet of Behavior is going to make the difference, right? So why and what it is all about, right? So the IOB is basically it is a user driven data. Okay, so the data is analyzed. Okay, the user driven data is analyzed through the behavior pattern, right, from the psychology perspective, and with that results of data, the we will perform the analysis. Then we can inform the new approaches on how to design the user experience for the final product. So if you start capturing all these user patterns, right, based on that pattern or behavior, so the businesses will be able to arrive at the new approach, right? That the way they showcase the products, right? The way they advertise or market or sell these products will entirely change, right? So this, no doubt, this will become the most powerful marketing or a sales tool, the Internet of Behavior, for many of the businesses and organization around the globe. Okay, so using that, they can get a deep understanding into the customers, which is necessary for every business, right? So there is no business can stand without the customer, right? So the core backbone of the business is the customer, and hence understanding the behavior of customer becomes a key, right? And what is in front next? What next is, so in order to leverage this IOB, right, the Internet of Behavior, so businesses needs to invest in IoT, and which is already we have seen in the traction, and the lot of IoT deployments are going on. And the edge analytics and data management infrastructure, artificial intelligence solutions, right? The security and privacy. So also to be equally important to analyze and extract the meaningful behavioral insights from the data. So as this IOB is getting into limelight, the importance of the IoT edge analytics, right, and also the security aspects are also becoming very key and vital, right? So the organizations use this data to influence the human behavior, right? So, for example, in order to monitor, right, compliance with health protocol, okay, during this ongoing pandemic, if organization can leverage the IOB via computer vision, right, where you can see whether the someone is wearing a mask or via thermal imaging, right, to identify those who have a fever, right? So that itself will be the big impact of this IOB, right? So it helps in bringing that influencing the behavior of the human. And the other thing which is happening on the upcoming trends is the 5G, right? So that has been spoke a lot, and it's still the early stage, and but there are a lot of investments going, a lot of industry gains or started investing in collaboration with the different startups in order to be early adapters for the 5G and edge computing, right? So if you look at 5G and the edge computing, right? So these two are like linked each other, right? So they both poised to significantly improve the performance of the application and enable the huge amount of data to be processed in real time. Okay. So how this is happening is the 5G increases the speed, okay, up by 10 times of the 4G. So currently we have the 4G, right, which is, if we by having 5G, that speed will go to like a 10 times than what we get. So you just imagine how things will be fast. So we're already seeing with 4G there's a lot more better in terms of the bandwidth. So whereas the mobile edge computing, right? So that reduces the latency by bringing the compute capabilities into the network closer to the end user, and that is where this mobile or an edge computing makes a difference. So the industry is already working on this MEC network, right? That is also called the multi-access edge computing, right? It's also called as architecture concept, which will basically enable the cloud computing capabilities and the IT service environment at the edge of the cellular network. And the on more towards this is at the edge of any network, basically, right? The computing capabilities at the edge of any network. So the basic idea behind this Mac is by running and performing this related processing task, right, closer to the customer cellular network, right, it can reduce the network congestion, right, and the application performance will be better. So that is one of the key things, and hence the 5G and edge computing is going to make the difference for the future, right? Then, so if you take an example of the Internet of Behavior, right? So if you are capturing the data from different sensors, right? There are, if you have seen, there's sensors installed on the parking, sensors on the shopping cart, right? There is cameras installed everywhere, right? So based on this different data which you collected, you will be always be able to make the behavior pattern of that particular buyer, right? And then you can have a personalized solution for everyone. So with the help of this behavior tagging, right? So and hence this future trend looks to be all about IoT to edge computing or edge analytics to Internet of Behavior world, and 5G being in the upcoming trend. We see a lot more better things for the businesses in the near future. Right, so with this we have reached to end of the session, and thank you very much for listening uh, so far, right? Very patiently. Now, if you have any questions, I'll be happy to answer. Any questions from anyone?
Sir, can you explain more federated learning? So, how it is different from automated ML? So, using automated ML also, we can find a suitable model for the data, different kind of data.
Right. So the only difference between the automated and the federated learning. So the federated learning is more like a social machine learning. Okay. So if assume you also have a data model, right? I'm also working on the similar kind of a data model, right? So, and I don't want to share the data which I am using for training the model, but at the same time, I wanted to get the model which I am doing will be trained by your data set. So, with the federated learning, you can only share the model with the other party, right? So not the data, and then the other party can use this model and train with his data, and then see the insights. Similarly, you can also use the others model and then uh,
Okay.
train the data. So that is like a social training each other. You can share and train the data. So basically, it is sharing the data model across
Okay, sir.
sharing data. Yeah. Any other questions?
So, which is this? Is there any site for this federated learning? This we can download the data. No, we can download the
No,
model and
it's still on the
try with our
right. It is still in the very early stage.
data. Any resources?
It is still on the very early stage of the research. So we have done this along with one of the a program which we worked with the one of our customers. So it's still not a, like a public for the federated learning. So most probably will not find a lot of these resources online yet. Does that answer your question?
Okay, sir. Yes, sir.
Okay.
Yes, sir.
Any of the participants have any questions?
Any other questions from anybody?
Sir, I got one. Sir, I have one question. So,
Yeah.
what are some of the platforms which are used for edge analytics? Can you throw some light into that?
Right. So we have the Edge Analytic platform from the AWS, like the IoT Green Grass, right? That's one of the platforms. So we have the Microsoft IoT Edge platform, which we can use. Cisco also has the Edge platform, and Google has the Edge TPU from the Google Cloud, and IBM Watson has an Edge platform, right? So these are all some of the Edge platforms available. Apart from this, there are also open source platform, but you have to use it carefully based on the merits of that platform, as it's going to be sensitive, right, to the data which you are processing at the edge. Is that answer your question?
Yes, sir. Yes, sir.
Okay.
Thank you, sir.
Any other questions from anyone?
So one more question.
Yeah.
If you go for edge analytics, It's not replacing the cloud storing, no? Here at Analytics, we are passing it to the cloud. Some data aggregation is used or not?
So there are two things here. So first thing is the edge analytics is not going to replace the cloud or a central storage. So we have to be very clear. Okay. The second, the data which is getting processed at the edge, right, which in turn transmitted to the the volume of data which you are processing will be reduced. So the analytics which is done at the centralized location, right? So you are doing as next level of insights which is being done by your edge on a smaller set of data, right? So that way, it will be more efficient. And having said that, this is a good point you also brought in. So on some critical business needs, you should also, though the edge is doing the computation and providing insights, if you feel that all the data, the raw data which is being collected from the machines is still required, you can still send it to the cloud for future reference. If you think that is critical to have the raw data which is used for processing, because once you lose the data, it will be hard to get back. So that decisions has to be made cautiously. So you should not just leave it, okay, now the edge is making the decision, I will only pick out of 1,000 data, I will pick 10 data and then store it to cloud. That is sufficient. So but some businesses it's sufficient, but in some cases it may be very critical, right? Like the medical and other things, every data point is important. So in that case, you will be still putting all of this data into the cloud. For example, in the autonomous vehicle and all, the data will not be, so it needs to be done, processed immediately, and that behavior or incident, all you need to record back to the cloud system. So that way, it has to be made cognizant decision on whether or not you want to still store the raw data into centralized cloud. Okay.
Okay, thank you, sir. It's clear.
Yeah. Any other questions?
So I hope that no other participants have any questions.
Right. I hope all of them are enjoyed the session and was very informative for you to take it further on your journey.
Thank you, sir, for sharing your insights, especially the difference between analytics and edge analytics, and bringing the recent research topics like federated learning, internet of behavior. That's entirely new term. So thank you for sharing your insights and your knowledge in this area. So on behalf of the EC department, the US College of Engineering, and the entire participants of this Federated Learning program, we want to thank you for accepting our invitation and joining us and spending valuable time with us. Thank you, sir. Thank you very much.
Thank you. Thank you very much. It was always my pleasure to talk to people and share the insights of the learning experience. So I'm happy to do much more sessions on this direction. Once again, thank you all for your participation. Thank you.
Thank you, sir.
Thank you. Bye-bye.
Thank you, sir. Thank you very much.
Thank you. Yeah.
So, dear participants, we will take a 10 minutes break now because we have been listening for this session for 2 hours. We will, so on my watch now it is 3:29. We will start at 3:39. Please don't leave. You can take a break. You can mute yourself and take a break and then join back up after 10 minutes. Thank you.